Namaskar my dear friends. So today we will see sensors, how we can interface sensors and their application circuits, what are the techniques to select a sensor, and how we can design a specific schematic to suit our applications. Alright, so let us see various types of sensors that we will be seeing in this 1 hour session. So first of all, we will try to understand what is pin photodiode and how we can incorporate that particular device in our design. IR sensors, temperature sensors, pressure sensors, so many other different kinds of sensors are also there. We'll try to take as many sensors as possible in this 1 hour session. So let us say first talk about pin photodiode. So pin photodiode, we will take two devices right now. One is 0805 package and one is 1206 package. You can see the applications for these two devices can be high speed photo detectors and small signal detection, proximity sensors. Okay, so this is the diagram that you can see, right? Let us quickly see the data sheet and understand what it is actually. So if you see this particular pin photodiode is from Vijay Semiconductors, okay, and the features is it is like surface mount and it is having package form of 0805. The dimensions you can see it is as small as 2 mm cross 1.25 mm cross 0.7 mm height, okay. Then you can see the operating temperature range is -40 to 110 degrees centigrade, and as I told you the applications are like this, okay. You can also see that this is AEC Q101 qualified, so it can be utilized in your automotive applications as well, okay. Next, the wavelength that will be like incorporated in this is 740 nanometer to 1040 nanometers, okay. So anyway, I don't have like to give you this all definitions of this particular IR sensor, I mean pin photodiode sensor. However, we'll just try to see what is needed. So the forward voltage that is applicable here is typical 1.1 voltage and 1.3 volt, okay, maximum. And as you can see, capacitance is quite small. It is around 7 picofarad and 2.5 picofarad when it is working, okay. Next, let's move to the circuit design, like how we can design the circuit for this particular pin photodiode. So once we come here, this is our pin photodiode. So I have taken VEMD 4110X01, okay. And when light comes into it, like basically it can be utilized for your ambient light sensors, okay. So once light comes, what will happen is there will be output that will be coming up. So I have taken a pin sense out and it will go to your ADC, okay. So what is the thing that you can do here? One op amp that you can take up, okay, which will try to make you buffer and like amplify the signal and give you the output. And this is my filter circuit, which is 100 ohm and 0.1 microfarad. If you want, you can reduce this to 1 nanofarad as well, okay. And if you don't want a filter, you can put this as 0 ohm and you can proceed, okay. And this will be not utilized at that time. Got it? But I'll recommend you give the filter. This is suggested. At the same time, you can utilize the op amp, which will help you out. If you want, you can play around with the values of this particular feedback capacitor, which is right now I have taken 10 picofarad. You can go up to around 47 picofarad, okay, or 33 picofarad is a suitable value for you. This one is most suitable value that has been selected for this particular package and this device, okay. So same circuit can be utilized for your this particular device also, which is 1206 package. If you want a little bit bigger package, then you can go ahead with this. Now, very important thing about this particular pin photodiode and related sensors, what I'll do is I'll go through a product selection guide and I'll help you out to find out your suitable sensors for your applications. So let's open. So if you come up with your selection guide, so there is a like a document that has been given by Vijay Semiconductors, okay. So it has optoelectronic sensors, and it has a list of infrared emitters, photodetectors, and optical sensors. Okay, so you can see, if you want, you can go ahead with optical sensor product portfolio. Once you click here, you will get it. I'll put this particular like document link in the description for your support. Then infrared sensors product portfolio, you can go ahead. If you want, I can just click and show it to you, like how does it look like. So once you see, you have optical sensors and you have ambient light sensors, reflective sensors, transmissive sensors, and long distance sensors. All right, so you click any one of them, you will get the complete product portfolio for your particular sensors. Okay, and you have wide range of applications and wide range of like availability that you can work around. Got it? Now let us move to our particular document. So first of all, you can see we have infrared emitters. Okay, so infrared emitter, there is a long list of infrared emitters that is supported by Visa Semiconductors. Okay, so whichever is suitable to you, you can find it out. So I'll suggest you go ahead with this 5 mm through hole package, and this is 5 mm package. Okay, so this is little bit bigger. If you want to go ahead with a smaller one, based on your space constraints, you can choose one of them. Now moving to infrared emitters, we have understood. My job is to like give you an understanding, like where you can find different kinds of sensors and what are their applications, and how you can like plug into your design techniques. Okay, so with these infrared sensors, you will need one you will need one inner sense PCB. So this lens PCB will help you to spread the signal or help you to emit the signal in a wider areas. Okay, now coming to the pin photodiode which I was talking about. So I have taken from the same device. Like if you want, you can take up a package of like TO18 package kind of thing also, which is working with peak wavelength of 900 nanometers. Okay, and which has a bandwidth of 430 nanometers to 1100 nanometers. Okay, then if you want to go ahead with another types of package, so you can see here we have 1206 package also. So this is the one which I have taken. So it has a peak wavelength of 950 nanometers and it has a bandwidth from 750 to 1050 nanometers. Okay, if you want to go ahead with lower package, 0805 package, so I have taken this particular one, VEMD 4110X01. Okay, so you have understood the list of infrared emitters and pin photodiodes. There are more, like even it has photo transistors. So if you want to utilize a photo transistor for your application, you can select one of them. Similar to that, you can have reflective sensors and analog outputs. Okay, and then you have transmissive sensors and analog outputs. So you want to utilize, then you can go ahead. So this is how we have ambient light sensors. Just now I have already taken this example, the EMD series. Okay. So all right, I hope you have understood, and from this document you will be able to find out which sensor is applicable for your particular application. Okay. Good. You have some digital sensors also, where you will have not analog values, like you will be getting directly one or zeros. So if it is present, it will give you high. It will, if it is not present, it will give you low. Okay. Now let us move to another sensors in our document. This document I will paste it to you so that you can like find suitable applications to this. Now coming back to the circuit, we have pin photodiode. We have understood how to design the circuit for our pin photodiode, and once light comes, there will be an output, or based on output label, because it is connected to an ADC, you will be able to find out whether, I mean, what is the measurement of the light that is available. So based on the light capacity, or like lightings, it will you can try to decide whether to switch on your lights or not. Let us say inside infotainment, or maybe like I mean your automotive applications inside the inside the car or something. Suppose light is very less, so based on that sensor, it will try to uh, take a decision and switch on your lights. Many people, what they do is they try to design in such a manner that whenever light comes, it will become a high, and whenever light is not there, it will become low, right? So based on that, it will decide, and what it will do is we'll take one LED here. We'll take one LED here, okay? So this is my LED, and let's say this is 470 ohm, and I have connected here at the output. So what will happen whenever light comes here, it will switch it on. Got it? So when LED is glowing, it means you will see that there is a ambient light that has been detected by the ambient light sensor, that is pin photodiode. Next, let us move to another sensor, which will be my IR sensor. So very like robust part number for this particular IR sensor is TSOP 13436. Okay, you can have another parts as well, and this is IR receiver module for remote control system. So you can see it has some of the features, like it has reached maximum performance, and it is having very high like immunity against lamps or LCD TVs or your Wi-Fi systems inside your home. It has very low supply current, okay, and it can be having a voltage supply from 2 volt to 5.5 volt. The application circuit is very simple, which I will draw and show it to you. However, this receiver circuit I have taken here. So you can see this is a supply voltage. So supply voltage, you can give it here. Let's say I am going to give you 5 volt or 3.3 volt through a resistor. Let's say this is value is I think it is 10 ohm to 100 ohm. So I have taken 100 ohm here. And then you can send the output to your microcontroller interrupts or somewhere, which will be telling you that yes, IR sensor has received some signal. Got it? So what will be the circuit for this? So let us say this is your IR sensor, okay? So what is going to happen? I have VCC pin. So VCC pin I have given 10 microfarad and 0.1 microfarad as decoupling capacitors. This is my bulk capacitor. Then this is 100 ohm in series with the 5 volt supply, okay? If you want, you can give your 3V3 also in your circuit. And the output after 1 kilo ohm, it is taken to a RB0 pin, which is actually utilized in our particular applications that we had used. So this is going to be going to interrupt pin, okay? Or you can go to your high-end, like if you're utilizing high-end microcontrollers, any pins can be acting as an interrupt pin, so there you don't have to worry about. Since I was using here peak 16F series 18877, so I have to be very particular to RB0 pin. If you want to utilize your MSP M0L1306, which I have lot of applications that I have developed, so any pins you can utilize in there. Now, very important ones that we will try to see now, the sensors are IR sensors or temperature sensors. So temperature sensors are utilized quite widely, and I find like LM35 is one of the best temperature sensor, very robust sensors, okay, and very sturdy sensor. It has accuracy of 1 degree centigrade, okay, and it can give you a 10 millivolt per degree centigrade rise in temperature. So let us say right now it is 40 degree centigrade, you are going to get, let's say, a 1.2 volt output. So if it is 41 degree centigrade, you will get 1.21 volt output, okay. So 10 millivolt will be increased. This is what the indication is. So here you don't have to do anything. What you will get is you have VDD pin, which will be like 5 volt I have given here. Simply this is grounded, and this is V out. It is going to go to your uh, ADC pin, okay. So you go to your ADC pin, and it will give you the value of temperature that you are going to get. So based on the temperature that is available around the sensors, it will give you the output voltage. You have to decide. So if you want to understand what it is actually, how it is going to decide the temperature, I will take you to the data sheet of this particular device. So let me find out LM35. So this is my this is my LM35. Okay, so you can see it has very wide range of applications, like it can be utilized in your power supplies, battery management, or HVACs, where like even very high-end appliances, home appliances like refrigerators or fridges and all, and then automotive also. Okay, now coming to the fact that how we can use this particular device. So you can see, if you want to utilize for high-end application, you can go ahead with TO CAN package, which is a bit costlier. TO92 package, I'll suggest you, like, you go ahead with this, because this is the neither very low cost, neither very high cost. It is most suitable ones. Okay, so that's the reason I have taken. Even TO220 you can go ahead. Okay, now coming to the fact that what is the values that is going to have be there here. So typical characteristics, if you see, or recommended operating conditions and all those things. So we'll try to go quickly here and see what is the values. Okay, so accuracy, as I told you, design limit is plus minus 1 degree centigrade, but typically it is going to give you plus minus 0.3 degree centigrade. Okay, next I was going to tell you why we are going to go into the data sheet. Is we want to see the different values based on the different temperature conditions. Okay, so that is available at the characteristics. Let me go into the table of contents. We have pin configuration and function, absolute maximum rating, ESD ratings, recommended operating conditions, thermal informations, electrical characteristics and limits, electrical characteristic, typical characteristics, overview, and functional block diagram. We have typical information and applications. Okay, so what we'll see is, we'll see typical applications. So typical applications, you have basic centigrade temperature sensors. If you want to design, you can aram se design. Okay, so your temperature sensors, you can utilize for your, let's say, 30 degree centigrade to 37 degree centigrade is our, like, body temperature. So you can go ahead up to around 41 degree centigrade, and this will give you 0.4 degree centigrade resolution. Okay, so 10 millivolt per degree centigrade, there will be a increase in the output. So this is very easy to design. Got it? And you can see application curve. This is LM35 or LM35A. It is having temperature error which is very less. Okay, so here let's not waste time here. Let us move to the directly the circuits that we have developed. So the circuit was very easy. You can directly take the output to your ADC and decide what is the temperature value. Got it? Now let us take another temperature sensors, which is LM35. Okay, so what I'm going to do with LM73 is, it is having SOT 23-6 package, and the best part is it is having a, like, capabilities of I2C, or like SM bus interface. Okay, so you can send the data through I2C lines. Okay, now this is my address line, which can be having maximum 3 selections. One will be like connected to the VDD pins, or connected to the ground pins. Okay, or connected, leave it floating. So there will be 3 possibilities. So I have connected it to high. So this is my address fixed. Okay, now whenever there will be, like, temperature rise beyond the limit that you have set through your I2C lines. So like, you can write down inside this particular device what is the temperature limit that you want to keep. Let us say this particular device has been, like, implemented in a like a near your applications. Okay, and you don't want the application to increase more than 50 degrees centigrade. Okay, so what will you do? I'll just remove this. So what will you do? I'll give a command that fixed your value to 50 degree centigrade value. Okay, so whenever there will be an increase in the value more than 50 degree centigrade, this alarm pin will go low. Okay, so low, why? Because I have pulled it high, okay, always. So till the time it is beyond, it is within the limit, like it is lower than 50 degrees centigrade, it will be high. Okay, so you will understand that, okay, my temperature has not increased beyond the limit. Now what will happen whenever there will be increase in temperature, like more than 50 degree, let's say 51 degree it has reached, then what will happen? There will be a low here, and you will understand that you have to either switch off your applications, or you have to decide what is the action that you should take, since the temperature has increased beyond the limit. Got it? Let us say another temperature sensor which is very user friendly. That this is from Microchip. Okay, so Microchip technology is there. So TC1047, you can see it has a typical accuracy of 1 degree centigrade, maximum accuracy is 2 degree centigrade. Okay, and temperature range minimum -40 to maximum 125 degree centigrade. So it can take up your temperature range from -40 degree centigrade to 125 degree centigrade. Got it? Now it can be utilized for your 2.5 volt to 5.5 volt range applications. So I can easily design an application with 3.3 volt or 5 volt supplies. Got it? It can be utilized in your cellular phones, power supply, thermal shutdowns. So like let's say you have a power supply and you want to shut it down at the temperature where it reaches, let's say 90 degrees centigrade or 100 degrees centigrade, and you don't want to run that power supply beyond 100 degrees centigrade. So once it reaches 100 degrees centigrade, you will be able to measure with this particular temperature sensor and you can shut it down. So there are more applications like even consumer applications or portable battery power supplies. So we'll see the uh, circuit diagram for this. So in this circuit diagram, what we are going to do is we have a 3-pin package which is SOT23-3. Okay, SOT23-3. So you have VSS pin, which is your ground pin. We have VDD pin, which is your power supply pin. I have supplied 3.3 volt here, and this is your V output. So V output is based on the temperature that it is receiving. So once the temperature is increasing, the output is also increasing. So you can take it as temperature out 1, okay, which is going to a ADC pin. Got it? And this is again utilized in our MSP M0L1306 microcontroller application design. Okay, so I'll give you a tutorial on this particular microcontroller with all these applications that I have put together and utilized a very good one. Okay, so this was from Microchip technology. Same temperature sensors you can utilize from Texas Instruments as well, which is bit lower cost. Like that was close to around $0.8 or something, and this can be as low as $1.14. Okay, so this is little bit recommended from my side. So Texas Instrument has very wide variety of temperature sensors, and many other portfolio is also there, but we are right now talking about temperature sensors. So what we are going to do, TMP 235, that is the part number. Okay, so the exact part number I have written here, TMP 235 A2 DCKR. So A2 is like there are two possibilities, one is A2 and one is A4. So A4 is little bit lower resolution and A2 is very high resolution. Okay, so as you can see, the accuracy is coming up as 1 degree or 1.2 degree or 2 degree. The operating temperature range is -40 to 150 degree centigrade. Supply voltage range minimum to maximum is 2.3 to 5.5. And maximum supply current is actually very less compared to the previous one what you saw, that was 35 microampere, and this is let us say, yeah, this is 35 microampere, and this is going to be 12 microampere only. Okay, interface type is analog output, so this you can send it to your ADC value, and based on the ADC values you will be able to find out the temperature value. Got it? As you can see here, there are some values that I'm going to take you, and I'm going to take the complete values as well. So at 0 degree centigrade you will be getting TMP 235 as 500 millivolt. Okay, so based on 500 millivolt you can decide you have 0 degree centigrade temperature that is achieved. Got it? Sensor gain, you can see TMP235 is 10 millivolt per degree centigrade and 236 is 19.5 millivolt per degree centigrade. So let us go to the data sheet of this particular device and try to understand the different readings of TMP235. So I'm going to go to TMP235. So this is our TMP235 data sheet, and you can see complete features and applications about this particular device. So you can see you have 235 as 2.3 volt to 5.5 volt and 236 as 3.1 volt to 5.5 volt input supplies. Okay, and this is 10 millivolt per degree centigrade. This is close to 20 millivolt per degree centigrade. Okay, so this is bit better. However, you have like A2 level, as I told you, it is plus minus 0.5 degree centigrade, and A4 is plus minus 0.1 degree centigrade. So I have taken A2 series. Okay, that's all. And the temperature working range is 235 is bit higher range, which is minus 40 to 150 degree centigrade, and 236 is bit lower range, which is minus 10 degree centigrade to 125 degree centigrade only. Got it? Now let us move to directly the values that I was going to talk about. So typical characteristics, if you see, we will be able to find out, or let me go and find the it has one more thing I want to say. It has two packages. One is SOT23-3 package, and this is SOT70-5 package. So 5-pin package and 3-pin package. So this is just VDD and V out and ground pin. So this is bit less available, like lead time is little bit higher, but this is having very good availability. And you can see these two pins are not connected. So ultimately it is also having only 3 pins, which is working. So circuit will be same for this as well as this both. Okay, next is as I was telling you about the values at different temperature. So I want to show it to you, like how you can find out your temperature transfer table. So this is called temperature transfer table. So I'm going to take the example of TMP235. So as you can see, for TMP235 at minus 40 degree centigrade, the ideal linear value is 100 millivolt. So if you receive 100 millivolt at your ADC, then you can decide the temperature value is minus 40 degree centigrade. So you will make a lookup table for your voltage value and your temperature range. So if it is 100 millivolt, you will decide that it is minus 40 degree centigrade. So whenever it is around this voltage, you will be able to find out very quickly. Got it? If it is minus 35, you are going to get 150 degree centigrade or 150 millivolt. Okay. Similarly, you can see for 0 degree centigrade, it is 500 millivolts. So it is very good value that it is like going to give you as output. 500 millivolt is very easily recognizable. You can see at 25 degree centigrade, it is having 750 millivolt. And let us say I have 26 degree centigrade, then what will happen? 760 millivolt. Then 27 degree centigrade, what will happen? 770 millivolt. Then 780 millivolt. And then 790 millivolt at 29 degree centigrade. Okay, and 28 degree centigrade, and then 800 millivolt at 30 degree centigrade. So for each 10 millivolt range, each 10 millivolt like difference, you will be able to get your uh, corresponding temperature range. So your 10 bit ADC or 12 bit ADC is more than enough. Okay, so 10 bit is also more than enough. Even 12 bit, generally the application which I have utilized is 12 bit ADC. So 12 bit ADC, it will be more than enough. Got it? So this is what I wanted to show it to you. Same transfer table is available for TMP236 as well. Got it? So let us quickly move to the circuit diagram. So circuit diagram, there is a recommendation from the data sheet itself. Like you have temperature, you have supply voltage 2.3 to 5.5 volt. you have bulk capacitor one, and then you have a resistor and capacitor as your low pass filter, and then send it to your ADC bill. Got it? So we'll do the same thing. This is our ground, and this is our supply voltage, which is going to give you 3.3 volt. If I want, I can utilize 5 volt as well. Then I have taken 100 ohm and zero point 0.1 microfarad filter capacitor. So this is my low pass filter, and I'm going to send it to temperature out to, which is your ADC pin of your microcontroller. Okay, got it? So this is very simple design, and you can utilize very easily in your applications. So just remember, this was TMP 235, and it is SOT 23-3 package, whose lead time is bit more, but it is well recommended device, and it is very good device. So same application I will decide with SC70-5 package. So what you can do is SC70-5 package, TMP 235A to DCKR. So DCKR is the complete part number. Similarly, the complete part number for this was A2DBZR. Got it? So with this, what we will do is, we have power supply 3V3, we have ground, we have V output, which is going after a low pass filter. So it can be like 100 ohm and 0.1 microfarad. If you want to take up more range of your low pass filter, then you can make it to even 10 nanofarad or 1 nanofarad. Okay, so you can increase your bandwidth. Got it? And you can send it to your ADC value as temperature out 3. I have set it. One more thing what I recommend you is, instead of sending directly to the ADC like this, you can take out from here. Okay, and even without filtering, you can send it to your buffer pin, and buffered output you can send it to your either your ADC, or you can put a filter and then send it to your ADC. Got it? So let me just clarify one thing here. What is the scenario that we are going to follow? This is our temperature sensor, this is the power supply, this is the ground. The output, we are going to take it to buffer circuit. Okay, and this buffer circuit will be filtered out with resistor and capacitor, low pass filter, and then you send it to your ADC. So instead of temperature out 4 here, you can take it temperature out 4 at this ADC pin and send it. Got it? So this is your final circuit. So hope you have understood many of the applications like temperature sensors and all these things. Let me take one more temperature sensors, and then we can close the sessions for the day today. So we'll talk about NTC. Got it? So it is negative temperature coefficient sensors. So I have taken one part number, which is like NTC ALUZ02A03. So its value is actually 10 kilo ohm at 25 degrees centigrade. It is very good temperature sensors with lug. So you can like easily connect with your motors, or your any applications that where you are going to utilize. And it has two pins, two wires, which can be connected to a connector, and this connector will give you the resistance value based on the temperature variations. Got it? So temperature ranges that is based on the resistance values, and this resistance values, you can see it is going to 4.7 k to 100 kilo ohm, and it has like tolerance resistance of around plus minus 1%, 2%, and 3%. It has B value 25 to 85, and all these parameters are there. I don't want you to get into these, but the thing is, where we can utilize this particular sensor is in computer equipments, in your power electronics and heat sink temperature control. So generally power supplies, there will be heat sink, and heat sinks are very good where you can like put a hole or something and give a provision for connecting this particular lug. Okay, then even in your consumer appliances, industrial appliances, and automotive equipments and everything. So let me give you the ordering information. So as you can see, I have resistance values at like different temperatures. So let us say I'm going to take up 10 kilo ohm values. So 10 kilo ohm values, you can see we have tolerance 2% or 1% also, and you can see it has the part numbers given here, right? So part numbers I'm going to select is G02103A and G01 103A. So G01 is actually 1% and G02 is actually 2%. Got it? So these two part numbers you can make a note. Like I'm going to tell you NTC ALU Z02103GA with 2%. So this is well recommended and very easily available with very low cost. Now coming to the temperature sensor circuit applications. So circuit applications, what you can do is you can connect your lug here with these two pins. Okay, so pin number 1 and pin number 2, and based on the temperature value, what will happen? There will be a resistance that will be rising across this particular pin number 1 and 2. Got it? So as temperature increases, the resistance value actually decreases. So what I have designed here is this is your supply pin, okay, supply voltage. Like I have taken 3V3. Then there is a 10 kilo ohm resistance here available. So what will happen is, let's say this is 10 kilo ohm. So let us say right now I have 25 degree centigrade, so value will be 10k. So 10k and divided by 10k, so it is going to give you half of the voltage, which is 3.3 divided by 2. Got it? Now this 3.3 divided by 2 volt is coming to the non-inverting pin of this particular op amp, and this is buffered. I have not given it is not used and it is 0 ohm, so I have not given any amplification. It is directly coming to a buffer. So here it will be coming up as 1.65 volt. Got it? Now after filtering, I am sending it to the ADC. So what will happen? The ADC value will receive a voltage of 1.65 volt and it will convert based on the ADC count. So I have utilized 12 bit ADC. It will give you a value of equivalent value. Now how it is going to work? Let us say the temperature is 30 degrees centigrade. So this value would have reduced to, let us say, 9 kilo, and if it has reduced to 9 kilo ohm, then this value will be little bit increased, right? Because once you are decreasing the value of above 1, the lower value will be increasing, right? So this is, let's say, going to reach to I mean approximately it is going to reach to, let's say, 1.7 volt. So as 1.7 volt it has reached, the ADC count will increase. Got it? So I have designed this circuit in such a manner that my temperature increase, my resistance is decreasing. However, the ADC value is actually increasing. So temperature increase, ADC count is also increasing, and this is how I will be able to decide very easily. There will not be any manipulation in our code. What is the particular temperature range? So alright guys, hope you have enjoyed this particular session, and if you do have any questions or any queries regarding your temperature sensors or IR sensors or infrared emitters or any kinds of like sensor related doubts, you can always reach to us. If you want, you can mail us at bkp semiconductor @gmail.com, okay, or you can WhatsApp at 809 8063. So you can WhatsApp at this place, or you can mail us for your any application related or industrial equipment related queries, or whatever the applications that you are working on and you are trying to find out the different kinds of sensors. So I have not covered pressure sensors. Pressure sensors very wide topics, and what I'll do is I'll schedule one more session for this and try to cover with great extent. Thank you so much.